here is a question 4, which says, in a geometric series, the sum of the first n terms is given by Sn is equal to p into 1 minus a half to the power n, and the sum to infinity of the series is 10. And 4.1 says, calculate the value of p. Now at first, you're probably thinking, what does this even mean? Okay, but let's break it down. So we are first given the sum of the first n terms. And we know that for a geometric series, which it is, there are two formulas for the sum. The first one is Sn is equal to a into r to the power n minus 1 over r minus 1, and the other is Sn is equal to a into 1 minus r to the power n over 1 minus r. So the first thing you might be thinking is, shouldn't we be using one of these formulas? And the answer to that is yes, we should. But instead, what they've done is they've given us a formula for Sn where they have already simplified, and they've got it in terms of p. Now, if you look carefully at this formula, you notice that it is more or less in the format of the second type. And why I say that is because if you look at what's inside this bracket, r, which is the base, the common ratio, is a half. And we've got it in the format as 1 minus r to the power n. That is exactly what we have in the second format, 1 minus r to the power n. So this equation that they've given us relates more to the second format of the sum for a geometric series. So what we can actually do is equate the two together. Okay, I'm going to start off by doing that first. Since both of these equations represent the sum for a geometric series, we can equate them to each other. So let's write that down. Okay, so here we have it. Now at the moment, there's nothing that we can do with this, but we are given another important piece of information which says the sum to infinity of the series is 10, which basically means that S infinity is equal to 10. Now we are also aware that sum to infinity has its own formula, which is a over 1 minus r. Since both of these are equal to the sum to infinity, we can equate them to each other. So I'm just going to split this page and I'm going to write that on the side. So for sum to infinity, a over 1 minus r is equal to 10. Now at this point, you guys will realize that the left-hand sides of both equations contain commonalities. They both contain a, they both contain 1 minus r. For now, here's what I'm going to do. I'm going to use a solving simultaneously approach, where since my second equation is the easier equation to work with, I'm going to make a the subject of the formula. So to do that, I'll take this 1 minus r from the bottom and I'll multiply it across, but I'm not actually going to distribute the 10 with the 1 and negative r. I'm just going to leave it as 10 times 1 minus r, representing the multiplication in a bracket. Now that I know what a is equal to, I'm going to take this value for a, and in the previous equation, I'm going to substitute 10 into 1 minus r in place of a. So let's do that. So where we have a, we're replacing it with 10 into 1 minus r. And we can keep the rest of the equation as is, which is the bracket 1 minus r to the power n all over 1 minus r. Right hand side is going to stay as is, p into 1 minus a half to the power n, and we close the bracket. Now at this point, you guys, it is extremely important for you to realize that You've got 1 minus r in a bracket in the numerator, and your denominator is 1 minus r. They can cancel out with each other. So here is what we're left with. On the left hand side, 10 into 1 minus r to the power n. And on the right hand side, p into 1 minus a half to the power n. At this point, you guys should realize that the left hand side of this equation and the right hand side are in the same format. What I mean by that is, if we look, let's compare inside the bracket first. So if we look at the bracket, it starts off with 1 minus r to the power n. And the bracket on the right hand side has 1 minus a half to the power n. So what does this tell us? It tells us that r is equal to a half. So r is equal to a half. And I know that is not what the question wanted. They wanted the value of p. The value of p is so evident. If you can figure out what r is, you can figure out what p is. P represents the coefficient of the bracket. And the coefficient of the bracket on the left is 10, meaning that p is equal to 10. So what we've managed to do is, we used a solving simultaneously approach. We made a the subject. We replaced a in the previous equation. We saw that 1 minus r cancelled out. And then we realized that, hey, the left-hand side and the right-hand side are in the exact same format. So surely those corresponding terms have to be equal to each other. Where the coefficient of the bracket is 10 on the left, and on the right it was p, so p has to equal to 10. And on the left-hand side, the base of n, so r, and on the right-hand side, the base of n, half, would be equal to each other. R is equal to a half. And also, not necessary for you to write this down, but one thing that we do realize now is that Sn formula which they gave us, p into the bracket, would actually be 10 into 1 minus a half to the power n. And I'm just putting this here just for future reference if we need to calculate the sum of any terms. Okay, so looking at the next question, 4.2, calculate the second term of the series. Now, there's actually different ways that this can be done. Since you know what r is, you can easily calculate a, and then you could get general term and use that. Or you could use the fact that term 2 is equal to ar. But there is another method that I want to show you guys, and the reason why is because this is something that is often tested, but it doesn't really show up as a set formula. So something worth taking note of is that if you've got a sum formula, but you need to calculate a term. So how it works is, and this is just a general method, a general equation of getting this, whatever term you want to calculate using the sum, it would be the sum of that many terms minus the sum of n minus 1. So Sn would equal, Tn, would equal to Sn minus Sn minus 1. And just as an example, say for example, you need to calculate term 50. Using your sum formula, it would be S50 minus S49. And it would work like that, no matter what you need to calculate. So seeing that we need to calculate the second term, so we need to get T2, so it's going to be S2 minus S1. That is how I'm going to answer this question. Okay, so here I have it, T2 is equal to S2 minus S1, and remember this is your sum formula. So for S2, I'm just going to calculate it in here. If you want to calculate the values separately and then substitute, you're welcome to do so. Okay, so I've just used square brackets around them to separate each one. Here is S2. We've got 10 into 1 minus a half to the power 2. We've replaced n with 2 minus, and S1 would be 10 into 1 minus a half to the power 1. And of course, you're welcome to just put this on your calculator and you should get 5 over 2. So that is what term 2 is equal to. Alternatively, say that you didn't like this method and you wanted to use something else. What I would suggest is calculate what A is. And since we know that R is a half, we can substitute a half in place of R and get A. And then we know that term 2 is equal to AR. So we would take the value of A, multiply by the value of R. Let's actually write this down so we can see how we would do this. So I'm just going to say or to show that it's a different method. So A was 10 into 1 minus R, and R is a half. That is going to be 1 minus a half is a half, 10 times a half is 5. So here we see that A is 5. And you guys know that term 2 is equal to AR. So from here we would have 5 multiplied by a half, and that is equal to 5 over 2.